The compact resist model and contour-based calibration in relation to Panoramic Technologies' new full chip simulator. This is an alpha version. The compact resist model is a rather ingenious resist model. I read about it in a paper by Yuri Granik, Proceedings of SPIE 6520. I believe he is the inventor of it. It's a very nice resist model. It's fast, and I believe it is a standard for the OPC companies. Since it is a standard, we thought it would be a good idea for Panoramic to implement such a model. And it turns out that this model is a nice fit for our full chip because it's fast, and it lends itself nicely to contour-based resist calibration. So I will demonstrate how our contour-based resist calibration works. The idea is that you have this calibrator program, and in the calibrator program you load in multiple patterns, multiple SEM images. That becomes a reference pattern which you are calibrating your resist model to. So for each pattern, you load in the SEM image and you load in the contours. By the way, the contours can be extracted from the SEM image using our Pan SIA software. So here I have two test patterns. These are SEM images with contours extracted. And you'll note also by pressing this button here, set calibration points on the polygon, it goes and finds important points here, and that is those become your reference points. So the idea is that you load in the aerial images. Now these are the aerial images that get created from a simulator like full chip or from Hyperlith. These can be bigger or smaller. They don't have to be lined up with the SEMs. There's an option to optimize the overlay on each pattern so that you could, in theory, just scan these images from paper and then extract the contours and load them in and not worry about the scale and the rotation and the translation. Let the program figure that out. So you've got basically your empirical data loaded, and you've got your aerial images. So the idea now is to work on the compact resist model. And this is our GUI for the CM1 model. That's again Yuri Granik's lingo, the CM1 model. And each of his modeling terms is put here. You can add more terms if you like. We're just working with two terms. The first term has a base quencher. We set it up as a variable because that's going to be tuned. That's going to be in the calibration. And then we set the S, which is the kind of like the blur, the sigma, also as a variable. And then we tune it. You tune it by saying optimize. And you give search ranges. This for right now, this is a hack, but you give a nominal value here, and then you give a search range here for value 2 and value 3, min and max, and then you press optimize, and it goes and finds the optimum of whatever value of variables. The optimum such that those parameters cause the contour to run through these blue points, which are just these points here, translated and rotated onto the aerial image. So once you're done that, you can save the resist model, and once you've saved it, you can load it into full chip or Hyperlith for usage. So in this calibration, actually, this is a real calibration, but not done on real data. This was computer-generated SEM image where we used our own resist model, which was not the CM1 model, but it was a different resist model, and we calibrated it to it. And it's nice to see that the calibration came out with 15.015 as the sigma and the base quencher of uh, 0.097. In the program, the other resist model, we put in 15 as the diffusion length, and we put in zero point 0.1 as the base quencher. So this found the right answer, and it actually has and it has a pretty good less than 1 nanometer RMS match, and you can see the match here. Anyways, there's a lot of work to do on the CM1 model. We may probably have to add terms other than what's in the paper. I know that other companies have met with success when they added different terms. And we would really like to get more data to test this out. So if anyone is interested, we're happy to work with you on your data and calibrate our resist model to it. And then we can give you a CM1 resist model that you could use in Hyperlith or full chip. Thanks for watching.